coming. I want to talk about creating better Phoenix context with DDD. And I want to talk about this because I actually found it really hard to create Phoenix context. I think it's hard when they were first introduced. I had questions like, there we go. What should we name the context, right? What kind of resources should it have, right? And when I asked that in Twitter, because I was going to make this presentation, I asked, what do people struggle with? Naming was one of the top ones, and really, how do we organize these things? Should it have a single resource? Should it have multiple? What kind of thing, right? So it made me start thinking about why were contexts even introduced in the first place? So if you go back to Phoenix 1.2, we had our Phoenix apps that were like this, right? Model view controller type pattern. If you come from Rails or Django or anything like that, this is very standard, right? But in Phoenix 1.3, they kind of made this stance on Phoenix is not your app, right? And so that transformed this into, we have our web layer. That's why we have my app web, right? And it had controllers, views, templates, and then live view came in later. And we had an app, which is a core business domain, where we have the schemas and presumably some other business logic. And I haven't talked to anybody in the Phoenix core team, but I'm assuming that what they were trying to do is nudge us in the right direction and say, hey, we've separated the web layer from your business app, but you should have something in there in between that communicates a boundary, and let's call that Phoenix context. Again, I'm not sure, but I think that's where this came from, right? So roughly speaking, I think they were trying to get us to stop writing this kind of code in our controllers and do something more like this, right? We have a context, check out, create product, right? Creates a nice separation. Now you say, nice history lesson, but I still have this problem, right? I call this the blank context problem, just like a blank page and you're writing a blog post, right? You start there, you have a cursor, you don't know what to write. We get here and we don't know what context to create. And I want to posit, I want to say that this problem is probably because we're doing database-driven design, right? Or schema-driven design, if you will. What I mean by that is that in your mind, you maybe have something like this in your head, right? You're talking about your domain model, and you're starting to make things like a user has many posts, and a post has many comments. The whole point is that our mental model is about entities and their associations. That's how we're doing this. And so when we get to this place, we know we want a product, that's the entity, but there's a question that we cannot answer. And I think that question is, what is a product in our business, right? And I think if we can answer this question, we can actually create better context. And I think DDD, domain-driven design, can be helpful in that area, right? So DDD gets thrown around a lot, so maybe it's lost all meaning by now, right? But what I think about domain-driven design is that the domain language, in fact, drives our implementation, right? And language is a crucial word there, right? So where we're going is I want to talk briefly about, not briefly, I want to talk about defining the context, what DDD can teach us about that. Then maybe does DDD have insights into what we should put inside a context, and then talk about outside the context, coordinating context and things like that. But as a side note, I'm not going to cover all of DDD. There's quite a lot of material, right? There's plenty of resources, but really I'm going to try to grab separate concepts from DDD and use them and apply them so that we can create better Phoenix context. So let's dive in, defining context. So what does context even mean, right? When the Phoenix core team came out with Phoenix context, I thought, man, that's a terrible word. I thought it's a terrible word because it's so generic. It's like namespace. It's both everything and nothing at the same time, right? But as I learned more and I did my own research, I thought, oh, actually, this is a good word because context means the setting or environment where something happens. And I like those words, those kind of synonyms, setting or environment. Because the setting in which we talk about things changes the meaning of words, right? Whenever you and I are trying to communicate, whether it's verbally or in writing, the setting changes the mental image that I'm communicating from my brain to your brain, right? That's ultimately what we're doing with communication, telepathy of some sort, right? Think about it in movies, right? We can be talking about movies. That's all we know. We're just talking about movies. And if I say wizard, I have an image in my head. Some of you may have the same image in your head, but a lot of you probably don't. There's a loss of information in that translation. And if we add another layer, if I tell you, well, let's think about the environment in terms of Harry Potter movies, now if I say wizard, you're not going to think of Gandalf, right? That's the wrong thing, right? You're actually going to think of Harry Potter, because now I've given you context. I've given you a setting. Same thing, if I say witch, you're not going to think of the Wicked Witch of the West, who, by the way, has never taken a shower, probably, because she melts with water. I learned that this year because I watched the movie for the first time with my daughter. you're going to think of Muggle-born Hermione Granger, right? Same thing. If I say a prison guard, and I'm talking about movies, you might think of many prison guards. But if I tell you in Harry Potter context, you're not going to think of Tom Hanks in The Green Mile. What a terribly sad movie. You're actually going to think of Dementors, right? Soul-sucking guards of Azkaban get driven away by Patronuses, right? The point here is that the setting, the environment, changes the meaning of words. And not only does it change it, but once I give you a setting, it refines it so that our communication, our telepathic communication, is actually better, right? And so context changes meaning. And why is that helpful? Because in domain-driven design, we want to start by understanding the problem space. The problem space is a domain in which your business is trying to solve a problem, right? So this might be banking, e-commerce, retail, whatever you have, right? And domain-driven design encourages us to talk to domain experts and stakeholders. Now, when I say domain experts, I don't mean people with PhDs who are producing research papers. I mean people who work in that domain, who are in that industry. And as you talk to these people, you want to listen for the language they use, how they use this language, how they describe the behaviors of the business, things that they might be doing manually right now. Maybe we're building software for them. Because as we talk to them, we're going to discover subdomains. And subdomains are pieces of our domain, but they have their own dialect. Right? We're using the same language, but it's slightly different. And the reason why we want to do this is because we are starting to understand that our problem space, which we thought maybe was a unified whole, is actually has like different groups, right? Different subdomains. There's core domain in there, and that's just because in DDD, when you talk about your core domain, it's like a specific subdomain that is kind of like the secret sauce of your company. Maybe you want to invest more time in that particular area because that's your differentiator or whatever. But it's still a subdomain, right? So by talking to the domain experts, you are beginning to understand that the way they use language is creating a different mental model of how they see the world. So let's take a look at a quick example. We're going to compare products, right? You may have a checkout product versus a billing product versus a fulfillment product. You come into this organization thinking, hey, a product is a product is a product. We just need an entity. But then you go to talk to the checkout people, someone who's been working there, and they say, you know, a checkout has a SKU, a name, and a description. These are the things we care about. Okay, you say, what happens when the customer needs to pay for this? They say, oh, no, we don't deal with that. We deal with billing. That's the billing department. So you go and you talk to the billing department, and they say, what's a product? They say, well, for us, a product is really a SKU, the quantity, and the cost per unit. These are the things we care about. And you say, okay, who does the shipping? And they say, well, that's fulfillment. So you go and talk to fulfillment, and they say, what's a product? It's, you know, they say SKU, a label that has the address, the quantity on hand, and the warehouse location. Right? The point I'm trying to make is that the product that you thought was a single concept is not the same. It's not the same across subdomains. In fact, what we want to do is separate our context by those subdomains. So if you think about it, this is what DDD recommends. So you have a problem space in which we've been working to understand the problem space and subdivide it into subdomains based on the language that people use and how they refer to certain concepts. And we want to map those subdomains into our solution space. So this is where we're now starting to implement code, right? So anytime you're doing domain modeling, you are trying to create a model, a representation of the real world in code. And typically, we come in and we think there is a single unifying model that represents the real world. That's what it means if we have a single product in our code base. But one of the cool insights about DDD, I think, is that you realize that that's not true. There isn't a single unifying model. There's like multiple representations that are based on dialects, right? And so that's what a bounded context is. So if you've ever heard of DDD, you've probably heard of bounded context. And what a bounded context is the code representation, right? A model of the world, the representation in code of a given dialect, right? But it's all in the solution space. So that's what the context is, but it's also bounded. And so in DDD, bounded contexts mean they are quite autonomous. They're separate. That's why we want to try to keep a boundary, so they're kind of independent subsystems. And because they're bounded, by default, bounded contexts will split our app, right? So before, I think the problem was that we had a product entity that we wanted to create, and we were thinking it this way. We want to have a single product entity that supports the entire app, right? We're kind of sort of coming from the bottom up in this graph. And the problem is that if you have a single entity, like, how do you make it support the whole app? What do you make the context? Product, the plural? Like, it's hard to think about, right? Because you're coming in from the bottom up. Instead, if you have bounded context, they naturally split our application, right? And so now each bounded context has its own product schema, and it might have its own product table, right? Because they're dividing that, and it's all, again, this is a code representation of something we discovered in the problem space. So let's take a look at a couple more examples. Here, this is a product that I worked on recently. It was a dialing kind of software, and we had calls. So these calls, you can imagine an agent going in and making some calls. And in addition to that, there was sort of this task management system that managed which calls are highest priority, this should be done next, that kind of thing. So it came in and they wanted to introduce background calls. Background calls is sort of a different concept where an agent can be in a room sitting and you're making multiple calls simultaneously and the calls get connected to them, right? So we could have gone in and said a call is a call is a call. Let's just grab the call table and add a background Boolean to it and throw it in there, right? Let's ship that, we're all done. But in reality, as we talked about more with people who knew about this, right, these kinds of things exist already, we realized that background calls is actually a completely different concept. The calls are used differently, the behaviors are different, and so we created a bounded context, a background calls bounded context, that then ended up using some of the task management system, right? So it communicated with that, and then we separated also the calls bounded context. So at the end, we had a really nice separation, right, of concerns. Another example, and this is hypothetical, and it's not an app that I actually worked on, but I think there's some cool things to talk about here, is suppose you have a blogging application, right? So you have a bounded context where the blog is very cruddy. An author can create something, update it, delete it, that kind of thing. But your blogging application also has a social component to it, maybe has a social graph, right? And when you start thinking about that, and you maybe start talking to people, and maybe it's just you're building this for the first time, the founder says like, well, authors create posts, but people follow other followees or whatever, right? So you're starting to think of different concepts. You're starting to hear different language. So maybe you separate that. And I included onboarding here because I think it's a cool mental exercise. I haven't done this. But if you think of onboarding, you might think that this is definitely something that cuts across concerns, right? But if you think about onboarding, you might actually have a guest, right? A guest is someone who's going through onboarding until they finish onboarding, and maybe they become an author at that point. Right? So another way to model this would be to say we have a user who has many posts, a user who has many followers, and a user who is inactive if they're in the onboarding process, and active once they're past the onboarding process. So that is how you design something if you want to have a single mental model or model in your code base. But I think this is a better approach because when you talk about it in the domain language, again, you want to listen to how the things you say and the domain experts say. They talk about an author creating a blog post. They're not talking about a user creating a blog post. They talk about someone following somebody else. And they talk about a guest going through onboarding, right? So another example of how you can break apart these bounded contexts, and the arrows mean there's some communication between them, right? Now, anytime you talk about DDD and talking about domain experts and do all these things, it feels like it's a lot of upfront planning and perhaps seems kind of waterfally. So just want to include this here, that DDD actually encourages a lot of iteration on design, right? So you understand the problem space, you implement that representation of your understanding, but the idea is that as you understand more and more of the problem space, that should be reflected back into your code. So you should be constantly refactoring so that your implementation matches your new understanding of the world. And so when you do that, you end up with this thing in DDD called ubiquitous language. It's the same language spoken from the domain experts through developers to your code base, right? So the idea is that you have the same language going through. Okay, so have we answered this question, right? Before, I said we don't know what the context is because we didn't know what is a product in our business. Maybe now we know, right? Maybe it's a billing product, and so maybe we throw that there, and then maybe we're done. Maybe this talk should be over, right? If you run this, it'll generate something like this, right? 6 functions that are very cruddy, right? Create, read, update, delete, that kind of thing. And if you have a CRUD-bounded context, I think this is great. I think go for it. There's no need to add more complexity when it's not necessary. But what I have seen is many bounded contexts, or maybe Phoenix contexts, end up like this. It's sort of like an explosion of the same 6 functions for n resources, right? And it really feels boilerplatey, and it feels weird. And you start asking yourself, should all of these schemas be accessible through the context interface? We're just sort of we're not modeling anything. We're just creating readers and writers directly to our database, but we just add in more layers, right? So it feels kind of useless. And then you start asking, where is the business logic happening? Who's coordinating these CRUD results? Maybe you have other modules, but what I've seen also is all of a sudden we're starting to sneak back some of the business logic into controllers and live views, right? We've accidentally broken that whole thing that I think is why the Phoenix core introduced Phoenix context. Again, not sure. So in fact, it may be that we can't use a generator for some of these cases because we need more depth, right? Maybe we want our context API to be narrower but deeper, right? And so maybe we need billing as the Phoenix or as a bounded context, something else, and then the product. So what does domain-driven design recommend for how we should define our bounded context interface? It recommends that, once again, we listen to the domain language. So we should express domain behaviors as functions in the bounded context, right? One helpful way to do this, it's not the only way, but I think it's helpful, is to think of events that then trigger commands. So events are things that happen in the past, and then it triggers a command. So one example is an order form submitted, right? You don't have to actually have this event in your code base necessarily. What I'm saying is this is how you can think about it, and then you know that your order-taking bounded context need to have a place order command, right? Because it's reacting to an event. In the background calls example, in the application that I worked, this was something we had. We had a callee join call. This was kind of a webhook that came in, right? That's an event, and so what the background calls bounded context needs to do is register a callee. So just helpful thinking events to commands. But this can also happen between bounded contexts. So in the blog post example, you might have a blog post created by an author, and that returns an event, and then the other bounded context can react to that. They can say, okay, the social bounded context needs to notify followers, right? And so this kind of, if you like visuals, this kind of ends up looking like this. We're creating a bounded context that is narrower but deeper, right? We are doing more of our domain logic inside what I call workflows. So that's defining bounded contexts and maybe a little bit of the interface. But what about inside the bounded context? What can DDD tell us about that? At this point, we want to kind of step into DDD tactical patterns. So everything we've talked about so far kind of falls under the strategic design umbrella of DDD. So if you're ever looking up terms, that's strategic design. Tactical patterns is a different thing. Now, many functional programmers think we shouldn't use these tactical patterns because they're patterns and they're OOP, right? And maybe there's some truth to that, but I think we can use them as building blocks and apply some functional techniques, and then it actually yields some really good results. So the first pattern is entities. Entities have two really important attributes. One is that their identity is defined by an identifier, kind of, you know, obviously, maybe. But they also have a life cycle, and best to understand by example. Here we have a bank account, right? And we can say this is the same bank account. Maybe it's across time, right? It's not necessarily at the same point, but it's the same bank account because it has an ID, and the ID is 2, and so we say it's the same bank account, but it's gone through some changes, right? So you see that it has a different status and a different balance, right? So that's an entity, maybe nothing out of the ordinary for you. But we contrast that to value objects, or in our case, value data structures. And these are descriptions of pieces of entities. They don't have an identity of their own, and their equality is measured through attributes. So an example is maybe the bank account has a balance, and maybe that's a money struct, right? And it has an amount and a currency. This doesn't have an ID, no life cycle. Really, they're equal. One is equal to another just because they have the same amount, same currency. And there's this other really interesting concept in DDD called an aggregate. Now, an aggregate is a cluster of associated entities and value data structures, so the two things we just saw. And they're aggregated together, but they're aggregated for a very specific purpose. It's not a hierarchical thing, and it's not like a random assorted collection of entities and value data structures. The whole point of an aggregate is that it should enforce consistency of data changes. And those data changes should not be just any data changes. It should be a business reason. They're called business invariants, things that should always happen together. And this consistency is actually transactional consistency. So in DDD, an aggregate should always be persistent in that transaction, so as a whole, right? So that you can enforce this transactional consistency for a business invariant. A quick example, we have an account, has an ID, it might have a balance. This is a value structure, data structure, right? It has an address, and an address is another value data structure. And as a side note here, you know, this is domain modeling. So this is not necessarily how we persist it to the database. We may flatten the address into the accounts table in the database if we want to, or it may be a one-to-one association, right? You might have accounts table that has addresses. And the interesting thing about that is that the address in that point has an ID. But that ID is a database concept, not a domain concept, right? So an address in this case, you don't always have to model your addresses this way, but I'm saying an address in this case is a value data structure because the equality of it is just based on its attributes, and it doesn't have a life cycle. So anyway, domain modeling, right? And then an entity can be associated to other entities. In this case, for example, the bank account has many transactions. Those transactions are each entities because they maybe have a life cycle and identities of their own. But the point of the aggregate is that all communication from the outside world goes through what is called a root entity. In this case, that's account. And once again, you can see this, an account has many transactions. But the point of aggregates is not hierarchical. So it's not because an account has many transactions that this is an aggregate, but rather it's an aggregate because there's some business reason, business invariant that this should be held together, always work together. In this case, it might be that we don't want other code outside of the aggregate mucking around with transactions and messing up the balance of the account, right? So maybe when you create a new transaction, we do it, or sorry, this bank account transaction, when you create a new transaction, we have to do it through the account entity because we want to keep that balance at the same time, right? The balance should be reducing basically the sum of the transactions. A couple other patterns are factories. These may seem very familiar, encapsulate complex creations of data structures. But in the domain-driven design flavor, they may do something more like this. So you have some, outside of the bounded context, you have some like unsafe, unknown data, right? In this case, if you look at this, that's a map, seems like it has an ID, has some, looks like a money attribute, seems to have an address and some transactions. Well, that factory can transform this from less structured data into more structured data. Again, thinking of the language we use in our domain. So we have an account, that's an entity because it has an ID. It has a balance, which is a money data structure. It has an address, that's another data structure, and it has transactions, right? So factories may be a little OOP. It sounds like object-oriented, but I think if you think of them this way, it's a really helpful pattern to transform less structured data that's outside of your bounded context into your bounded context domain concepts, right? And the last thing is repositories. This is not an Ecto repo, but it's a collection of entities of a given type, and it's really an abstraction over the persistence layer. An example of this might look like this, right? So Scout is the application, blogging is the bounded context, posts is the way I define the repositories. And if you look at this, you say, hey, this looks an awful lot like what the Phoenix context generators generate for you. And you might ask, is the bounded context the Phoenix context, or is this the Phoenix context? And I say, that's a good question. I think the reality is that if you have the simple case of a very CRUD bounded context, this kind of collapses down, right? You don't need these layers. But if you need the layers, this becomes a layer on top of your schema so that you can actually kind of abstract that chain set manipulation in here. So, okay, those are the building blocks. But how does that translate to functional programming? Can we use it? Yes, I think so. We're going to use function composition to do it. So we're going to think of aggregate operations as pipelines. What do I mean by that? We tend to have an initial value that comes from outside the bounded context, or maybe something else. But we use a factory type pattern to build from less structured to more structured data. We use the aggregate to transform that data in some way, keeping those business invariants, and we use the repositories to save that. Now, if you squint at this, it actually starts looking like this. You have an initial value, you're building some type of token, you're transforming that token, and then you're persisting it. And that actually is a tokenized pipeline. And this is very, very common in Elixir, right? Plug connection struct, ecto chain sets, ecto multis, the stream data structure, right? All of these things are very common. And so the idea is that you can actually apply those building blocks and create a nice tokenized pipeline. So in practice, this might look something like this. You have a create product function. We have some set of params. We are building this. So I tend to use the plural of the resource, just because it would be nice to use the singular resource, but that's what Ecto uses for the chain set, so I use the plural. So that's our factory function, if we need it. Then we perform some aggregate data. I call it validate here, but it could be something else. You should follow the domain language, what kind of transformation the aggregate is supposed to perform. And then if we need to, we insert this, save it back into the database. And this kind of function might transform from our from our domain data structures back into a representation that we persist to the database, right? So in the other example, maybe we flatten that address back into the bank account data structure, or table, sorry. So the other nice thing about this is that in the simplest version, I think this collapses kind of down to this. And this is the normal Ecto Phoenix things that gets generated, right? So I like that because there seems to be some continuity between these things. So in the simple case is this, in a more complex case, you get something like that. All right, so now we have these composability of operations, and we have talked about workflows and the bounded context. How do we marry them, right? And once again, we just want to use function composition here. So this is an example of a bounded context and background calls. And we're going to assign a call to a room. And what we're going to do is we grab one aggregate. And this is sort of like a cache layer where you're getting the next available room that returns a room ID. And then you pass that to the other aggregate. And so this is where we're composing functions. This aggregate knows how to fetch its own rooms. And then we perform some business invariant kind of action right there. So this is a sign active call, right? Now, I want to touch briefly on queries, because as we talk a lot more about this, as we've been talking about this, it's easy to think about business processes, things that write to the database, but what about queries, right? We need to read a lot in Phoenix applications. So when I say bounded contexts are broken up into workflows, I tend to think about them in terms of commands and queries, right? So I mean both of them with workflows. I mean it more generically. So if you have a simple query, I think you just use the normal query, like get product, return the product. I'm not going to touch on that case necessarily. But what if you have a more complex query? So this is an example from, again, this background calls project. And we had a dialer, right? A dialer is not necessarily something that's backed by a schema. But if you think about the web layer as something outside the bounded context, we don't necessarily want to expose all of our schema infrastructure to the web layer, right? We don't want the view or some other code up there to have to do the traversing through the room to get calls and do all these other things, right? We don't want to have that logic there. So what I tend to do is use aggregates. So we get the aggregates. In this case, we get the room and the active call. And we create a new data structure, once again, kind of following the tokenized pipeline, right? We create a dialer data structure. We put the room and the active call, and we perform some transformations on it, and we send that on its merry way. All right, so that's all inside bounded context. What about outside bounded context? What can DDD tell us about this? First, let's talk about how do we compose these contexts, right? I like the idea of composition throughout this whole thing. And if you haven't noticed, we've been building the Death Star. So one thing that I got from the Domain Modeling Made Functional book, this is not in the original DDD book, but I like the idea of use cases, right? So if you have something that's a use case that kind of encompasses multiple bounded contexts, and we saw that in some of our previous examples, right? Like maybe an author creates a blog post, but that also should have some repercussions in the social graph, right? Maybe the followers need to be notified or something like that, right? Well, we want to combine context. How do we do that? Well, there's an example here, an agent joined room, right? This is, again, a use case. It kind of represents a use case. And when an agent joins a room, what happens? So in this case, we get an agent ID. The first three functions there are a single bounded context, right? Background calls, we're dealing with that. But if you look at the start dialing session, that is going to hand over something to the task management bounded context. So how do we compose these things? Let's take a look at the start dialing session really quick. The way we compose this, if you just look at the return value, that has a dialing session started return value. And that is just an event struct, right? So an event is a data structure that has the minimum amount of information that we can share with another bounded context so that we don't couple the two bounded contexts, right? So events, if you think of event as Elixir structs, it actually creates a lot more boilerplate. Think about all the events you might have in your application, and you actually want to define a module for each one of those, right? It's a lot of boilerplate, so you might kind of feel reluctant to do that, but it actually reduces coupling between bounded contexts. I think the alternative is to do something like, if you have the background calls start dialing session right there, you could call the task management update task function, not after that, but inside that bounded context, right? So that's kind of the direct calling that I have right there. And that is a lot less boilerplate, but it's a lot more coupling. And it kind of breaks the whole idea of bounded context, right? That's why they're bounded. They should be separate, kind of like autonomous systems that don't rely on each other. All right, so this looks beautiful. And I wish all the code looked like this, but in reality, at this point, you might be dealing with errors. So it might actually look like a with pipeline, right? So just kind of as a side note, so you don't think, oh man, why do I have to introduce with pipelines? He did it so nicely in his slides. It probably looks something like this, right? So we have the start dialing session, I pulled that right there, but then we pass that event to the task management system. All right. So here, just as a side note, we've been talking about events and events and events and events. I'm not talking about event sourcing. I haven't even talked about publishing events, right? So I want to make that distinction because sometimes when we hear events, and in particular events in combination with DDD, your mind just jumps right there. Oh man, we're introducing this whole machinery, complicated, all this stuff. But no, events are just data structures that are allowing us to decouple our bounded context. Now the nice thing is this is pretty functional, right? We do write to the database, but it's really functional composition. And at this point, you can add whatever you want in OTP, right? If you want to do more asynchronous processing of these events, you can publish them, you can subscribe things. So there's a lot more you can do at this point and add it to it. But in the simplest version, you really don't need any of that, right? You're just using function composition, and you're not even publishing events across bounded context, right? You can just compose the bounded context because they're just data structures. So once again, your domain language drives your implementation, right? And so we can have our app that has use cases. Those use cases can have coordinate bounded context. We discover our bounded context based on those subdomains that we've talked about. And each bounded context can be composed of aggregate operations. And each aggregate operation is kind of like a pipeline of a tokenized pipeline, right? It's kind of like a fractal of things, if you will. So my name is Germán Velasco. I do Elixir and Phoenix consulting. You can find more of that in GermánVelasco.com. I wish my website was elixirland.com, but no. GermánVelasco.com. I do stuff with like team augmentation or building MVPs, helping you build your products, mentor developers, and also TDD training. If you love TDD, I'm your guy. And you can also find me as Germsvel on Twitter, or X as I like to call it. I also post some short videos on Elixir streams. If you'd like to watch those, they're quite a lot of fun to build, to make. And if you want stickers for that, I have some. And thank you so much for your time. Really appreciate it.